This is Mike Duffy. It's my student project for Engt 196. This project we had to demonstrate proficiency in the different workbenches such as sheet metal, kinematics, prismatic machining, and knowledgeware. So for the start of this video, right here I am putting in some parameters for the knowledgeware to control the different sizes. What I ended up making is a box, sort of like a toolbox, with a tray on the inside that lifts out, which is the sheet metal portion will be the tray, and the boxes and the lid are machined out in the prismatic machining, and the box and the lid and the tray are all connected by knowledgeware, and the screws are made with a design table. Here is my sketch of the box. Let's see, I'm linking my parameters to it. Edit the formula there and add the parameter. You can see the cursor's moving around because I was explaining things as I was recording the video, but I ended up with hours of video, so I had to edit it down and speed it up. You can see parameters working to control the size of the sketch there. Which will control the size of the box. There's the radius there. Corner radius. And now we're going to make the pad. And I'm going to use a formula for that, or a parameter for that. Now we'll make a couple of pockets here after we, demonstrating the parameters here. Now, you see my sketch there. I made it one single sketch, and I'm using the profile definition to pocket different pockets of different depths from one single sketch. Here's my first pocket there. You can see where the lid will sit. It's that first inset. Now I'm making a second pocket, and this is going to be the ledge where the shelf sits. And so what I did there was I used the parameter and a formula to hold it, maintain that depth centered no matter what the height is. So it's linked to the height divided by 2. And there's the depth of the overall box, and that's also linked to keep the bottom thickness regardless of box depth. And now we applied a little material. And we're putting a little fillet on there. Now I'm going to make the sketch for this is holes now. We're going to drill a couple of holes because it's going to have some hinges on it. So we're going to drill and tap these holes. And so I made one hole. And then use the pattern feature to create a second hole. You can see all 4 of them in there now. This is how I did it with the pattern. So I used one hole, use that edge for my direction, set my distance, and I did that from each end of the box so that they would stay the correct measurement from the end of the box even when the width changes, as I'm showing here. That was the height. I was showing the shelf in the middle, but this will show, this is the width. And now the length, and you'll see the screw holes move with the size of the box as well. Except for a little lettering in the bottom there for later, will be cut out in the prismatic machining process. Right now I'm creating the lid, applying some material to it, and it obviously is linked as well to all the box parameters, using formulas and parameters. So the lid will change sizes, and the plane that it sits on will change in accordance with the size of the box. Now I hid the lid, and I'm going to go into the sheet metal design workbench, using some more parameters and formulas to control the size of the sheet metal box inside the insert. And creating myself an axis there. And that axis sits right on the corner of that little ledge and also moves in accordance with the height. And I'm sketching right on that plane there. Make some sides for the tray. And there it is, finished with the 4 sides done and 4 bends into the corners to round them off. You see a little gap in the corner down at the bottom because it's sheet metal. Now, what I'm doing here is I'm laying out for, I use the bridge feature to create a little handle to be able to lift the tray out with. And right now I'm linking it so it stays centered in the middle of the tray. And there it is. It's going the wrong way, so I reverse the direction. Now I'm going to change the angle a little bit. Add. I think I like it there. I'm going to add a little radius to the corners, top and bottom. And there it is. Now we have a handle. And there's the completed tray with some little indents punched into it for placing things in. And that is what I ended up with on the tray. I took out those ones on the side, or in the middle, along the sides. It was too busy. It's a nice, simple, basic box with nice, clean lines. I like a real classic look like that. I don't like a lot of fancy things, but some people do. Nothing wrong with that. And there I'm showing how you can change the size, and everything updates and changes accordingly. Now we're back in part design, and I am making the hinges for the lid. What I'm doing here is I am using the formula and the parameter to set a axis point there tied to the height of the box, tied to that parameter. And now I'm making a plane based off that axis linked to the length of the box for the hinge on the far side, so it will always be so it'll maintain its edge distance from the outside edge of the box. Now, selecting sketch plane. And we're sketching right on that plane that I just created. You can see I already have one hinge made. Now I'm just going to demonstrate how I did it. Let's start with a circle. And a rectangle. And another circle. And that's the basic outline of the hinge right there. Set the correct value for the diameter of the circle, and I'm going to use a geometric constraint to hold it concentric with the other circle. Using geometric constraints to link the rectangle with that line I made. Hold it coincident to the circle. And I delete a couple of those lines. Set that dimension for the edge from the center of the hole. And use another geometric constraint to hold the top edge even with the center of the hole, and put a little radius on it, a little fillet, and it's done. The sketch is done. Now we use a pad to bring it out how long we want it. I made them 1 5/8 inches, I believe. Now I am going to put the screw holes into it. And like before, just using a screw hole. This time I'm just basing my dimensions right off the edge of the hinge itself, so they will always be tied to it. Last thing we want is for the hinge to move and the hole to stay where it was. Okay, and you can see I went to wireframe there in my view just so I can see and select that other hole so I can make them concentric to each other. And we had a little crash there. Now it's back open, and we're going to tie these together here. what I'm going to do is just make this circle concentric with the other one. And there is our countersunk hole and the hinge. Now I'm using the pattern feature to copy it. And for the most part, that hinge is done. We're going to add some material to it. Just a little shade darker of material so it stands out against the box a little bit. And there we have it. Now I go in and insert a new part in the assembly so that I can create the second half of the hinge. I'm basically repeating the steps that I used before. And create the pad for that one. And now sorry about that. Now I'm creating a sketch to cut a pocket out of the hinge barrel so that the two hinges can sit together as they do with the pin going through them. So I need to remove a section of the barrel from this hinge, and then on the other hinge we'll have to remove, obviously, the mirror opposite section. As you can see, that one already has it cut out. So what I'm doing here is I'm just using I used the geometric constraint to hold it even with the cutout on the other side, and I set my distance, how big I wanted it cut out from the edges. And now I've got my sketch. I go to the pocket feature, and it's right in the center there, so I just pocket it both ways up to the last, and there it is. Now it looks like a real half a hinge. We're going to put just a really small little fillet around it just to knock off the sharp edges. I think I went 1/32 of an inch there. Now it's time to put holes in the opposite side of the hinge. So I'm using the hole feature or command. And I'm going to basically do the same thing I did here before. I'm going to go into wireframe so I can see through the part. And just delete out those two dimensions, and I'm going to use a geometric constraint to hold it concentric with the other hole. You see I selected concentricity there. And it looks like there's no hole underneath it there because of the ledge and the tray inside the box, but you can see a little line there. That's actually the edge of the ledge it's sitting on. So there is a hole through the lid there. It's just a trick of the positioning. Now we're making the pockets for the other side to cut out the hinge barrel. And I'm going to use geometric constraints here to link them up evenly with the other side. And I link those two together. Make them equal. And there's my sketch. Now I go and pocket those out as well. Use the pocket command right there. And now we have our hinge. And you can see I didn't quite get that hold distance. I forgot to set the distance there, so I correct that real quick. And now we're going to add some material to the hinge. And now it's time to create the pin for the hinge. So I just make a simple circle using the intersect command. And the pad, and there it is. And add a little material to it, and it's done. Now I'm showing changing the size of the box, change the parameters. You can see the sizes change. That changed the outside radius there on the corners. Now we're going to change the length. And it looks like nothing is working, but that's because when it's in the assembly like this, you have to update the entire assembly. Once I'm done changing the parameters, I will update the assembly and everything will come together just like it's supposed to. Beautiful. Now I'm going into another sketch. Make a circle. And this is where I'm creating the screws for the hinges. And so I'm making two circles in my sketch, one for the body of the screw and one for the outer head diameter. And here I am creating a couple of parameters for them. Here's one for the screw diameter. And I make one for the length. There's my body of my screw, and I'm cutting a little relief on it for the countersink using the groove feature. And now it's time to make a Phillips head in the screw. And what I did is I used just a simple rectangle in one sketch, centered on there. Using a symmetric constraint. And now I made a second sketch. So I did the outside profile. I wanted it to the shape, and now I'm doing the profile of the pocket of the screw itself, or the pocket of the screw head. Put a little radius in there. Now I use the combine feature to put those two sketches together into a solid body. And you can see it there beneath the surface. Now I'm using the circular pattern feature to as you see, create the Phillips head shape. Now I've got that there, and what I want to do is use a Boolean operation to remove that body from the other one. And there's the screw head, just like that. Now I am selecting the parameters that I want to use in my design table for my screw. And I'm about to create the design table. And as you see, it opens into a regular old Excel spreadsheet. And now you can use your spreadsheet talents to create a design table using the parameters that you set up already before you even started making the part. And you save it and close it. And as you can see, I'm on the very short one there. Now I change the length, select a different length from the table, and it changes there on the screen, just like we want it. And there is the box. Now that that's finished, okay, that was a bit of a long pause. Okay, now that that's finished, we are going to go ahead and we are going to add a kinematic joint. And what I'm going to do here is name my mechanism. And now that that's created, I can create a joint. I'm going to select a prismatic rotating joint there and select the plane that I want to rotate around right there. And now we do the other side. Okay. And now I'm attaching a motor to it and getting the parameters of the motor set where I want them. And we're going to give it a test run. And there it goes. I'm playing around with the speed here a little bit, trying to get it to go. There we go. And that is our lid opening and closing with the motor. The fun of kinematics. And now I'm going to add another kinematic joint to the box and the tray so that the tray will lift out of the box it's in as well. And use the robot there, set the height. Now test it out. Okay, and it's not moving the way I want it to. It's moving down and only a little ways up. So what I want to do is go into the joint itself and adjust the parameters. I unset that center dimension and I set my limits high and low. Grab hold. Now it's doing what we want it to. Alright, now we add a motor to it by going into the simulation workbench. Oh, I'm testing here to make sure it all works. Hide that line. It's just an external reference that was not in hide yet. Now you can see I switched workbenches to mechanical systems design, so now I can simulate and operate that motor. That's the workbench you need to be in to run the motor simulation. And hide the lid there so we can see. Parameters are where we want them. Now we do our motor. It looks good, I think. Now make a little change. And simulate the motor. And the tray lifts out of the box just like we want it to. Perfect. Now open the lid, lift out the box, put the box in, close the lid. Unfortunately, I can't sync the motors up for it to work that way. The lid passes through, or the box passes through the lid. I still need to play with a few commands that haven't been taught to us yet, but I think I can play with to figure out how to make that work, but it's going to take some time. That'll just be something I do for my own knowledge, not for the assignment. Now, I am over in the prismatic machining workbench. As you can see, I just set up a generic 3-axis machine. I've got my lid here. I'm going to create the rough stock that the lid will be cut from. So we just add a little bit to it all the way around. And I'm showing the different ways you can do it here. I'm talking about it while I'm doing it. If it looks a little sporadic and the mouse is flying around the screen, that's what I'm doing. I'm talking and trying to gesture while I'm doing it. It doesn't translate well when I edit the video and then do a voiceover later. There is my rough stock on my lid now. That's what it's going to be cut out of. So now I'm going to set up my part operation. And select the safety plane. I'm just going to select the top of the stock. There, I select my stock. Now I can hide it. And select the part. Make sure my collision checking is on. And we're good to go here. Now I'm going to create a couple of tools. We're going to need a face mill. And an end mill. I'm going to need a really big end mill for this. I need a very deep end mill because of the height of the box. Normally this isn't the way it would be done. But just for the sake of showing the operations, this is how I did it on here. But so far, for the lid, all I need is just a standard end mill and a face mill. I'm setting up my part operation here, or my facing operation. Selecting what kind of tool path I want. Go back and forth instead of helical there. Set my depth of cut. And now we are reselecting the profile because I wasn't happy with what the result I was getting, because it was just following the profile of the finished lid and not facing the entire block, but now it will. And run a simulation. See what happens. And that looks good. I'm adjusting the macros a little bit, it looks like. I must have had a clash. Oh yeah, and so I'm setting macros to the macros for the finish pass, because I set it to run a finish pass, but I didn't set macros for the finish pass, so I had a little tool stock clash. Now I recheck it. Now I've got no clashes. And I'm going to run a profiling operation now to cut the shape of the lid. Select my profile. Now I'm going to simulate it. Not happy with that, so I'm going to make some changes. We'll try it again. And I can see I've got a fault happening. Got it fixed now. I guess I skipped that. So now we're setting up a drilling operation for the holes. I'm going to switch that to a through hole. And then we're going to select our geometry. Select the holes. And we're going to run the whole program here. Face both sides, cut the profile, and drill and tap the holes. There we go. That's our lid. Now we are going to do the programming on our box. This is the facing operation. Okay, now we're going to do the first pocketing operation. And now, I skipped over some. Now we have the entire tooling run here for the whole box. There's the facing. Now we come in and cut the first pocket, the second pocket. I skip a little bits for time in here because some of these take some time. Now we're into the third pocket, down to the bottom. Now we're going to cut the profile. Get ready to slow it down here a little bit. And this is going around and sharpening up the corners a little bit. And then now we move in for the little fun bit. Once this is done, and we start our lettering here any minute. There we go. And you can see we're gonna cut out the lettering. No one ever said they had to be in order. No one got moved somehow. That's alright. And look at that. Oh, it's the name of the class. And we'll let this power through the rest of the pocketing operations for the lettering. And there we have the last little bit, the last number coming in right now, Engt 196, Mike Duffy. Alright, now we're going to slow her down. It's about to run the drilling operations for the holes and cut the fillet around the outside, the outer radius on the top edge. Here that comes right now. Here is our screw holes. I don't know if it's coming through very well on the video, but that drill bit is peck drilling. And there's our outer finish cut on the outside. That was part operation for that. Now we're going to stress test the lid. I put a clamp on the end there. I'm gonna put a force right on the pushing up from the bottom, right in the middle of the lid there. We will simulate the results. As you can see, it's got a little bit of a warp to it. It bent a little, and you can see that's just the this deformation of it. Now we go to displacement. Oh, look at all that red. And this is von Mises stress scale. Next is factor of safety, and I think we broke that by putting too much force on it because nothing happened there. This is the reaction force vector. And finally we have compression and tension. As you can see, the bottom is pretty much exactly opposite of the top. Now what I did is I went and clamped both ends of the lid. apply one to this edge right here. Or is this... Okay, this isn't... What I did here is I clamped one end and I added a rotational twisting force to the other side of the lid. So we're twisting it against that clamped edge now. You can see the rotational arrow there showing how it's turning. And now we look at our simulated results. Oh, what happened? Oh, now I'm doing another setup. This is the setup where I clamp both ends and apply the same force to the middle that I had in that first analysis. So now I'm going to do that one first. Now this is pushing up in the middle with clamps on both sides. That is the... Okay, now we have displacement. Next is von Mises stress. Look at that. And that's the factor of safety. The reaction force vector, those red arrows, that's a lot. You can just look at it bending there. And the compression and tension. It's pretty straightforward there. Now we're doing the twisting, which I thought was really neat. As you can see it really torquing on it. It's getting a good twist there, a lot of torque against it. You can see it bend. Whoa. Now the von Mises, you can really see how the stress spreads out across that thing as it twists. And then we do our factor of safety, which is kind of broken. And this is the reaction force vector. You can see those. There's a lot of force generated against that clamped edge there. And the compression and tension. That's a lot of both. And so that was that. And because I had so much fun doing it, I decided to build a chair and see if I could break it. So here I am with some legs. And make 2 circles and mirror them. Now I'm going to set a plane where I want the seat of my chair. And we'll sketch out our chair seat on that. Set our thickness, then bring the legs up to it. I'm going to set a plane at a little bit of an angle there for the back. We set our circles and mirror them for the two outside supports and the inner vertical supports. Added some teak material. Now we have a chair. Now let's try to break it. I'm going to go ahead and add a clamp to the bottom of all 4 feet. And we're going to put a load on the seat, pushing downward. And then also a load against the back, pushing outward. Simulate that and see what happens. Ooh, that's a lot of bending. Oh, wow. The Von Mises, you can see a lot of tension being put right on those uprights and those 2 back legs. You can see the force against the feet. And look at that. I think you can see exactly where that thing breaks.